The sea is full of mysterious patterns, and if we can decode them, we might better understand the origins of life itself. These are the skeletons of Radiolarians, some of the smallest and most complex of creatures on our planet. Each only a fraction of a millimetre long, but they exist in their tens of trillions of tons, and in many places their accumulated tiny bodies cover the entire seabed. This is what it looks like, magnified thousands of times. Radiolarians are related to amoeba, and they're single-celled organisms, but they almost break down the idea of what it means to be a single cell. They have two layers, an inner nucleus, which makes them buoyant, and an outer layer. Nobody really knows why there's two separate layers, and they only live for 2 months, so how on earth did they make this complexity in that short time? How can a primitive organism come up with so much detail? Is there some trick as to how these life forms, and maybe all of us, get this complexity? Earnst Haekel, a brilliant Victorian marine biologist and illustrator, drew thousands of these detailed drawings with the first sophisticated microscopes that were available in the 1860s. Just for fun, I cut out and animated some of these drawings of Haekel's to imagine how they'd look in the sea. But it was the genius D'arcy Thompson who wrote an amazing book called On Growth and Form in 1917, who first understood some of the principles that allowed such complexity to come from such simple creatures. The skeletons of Radiolarians are made of a kind of opal, which we know from jewellery. Basically silicon oxide, which is plentiful in the sea. But how do they build this intricate, tiny lattice work? In his book On Growth and Form, D'arcy Thompson suggests what is still the most likely theory. When you see these beautiful forms, what they are the dead skeletons, and in life they have tissue around them, cytoplasm. D'arcy Thompson thought the cytoplasm was arranged in bags, or what he called vesicles, which are a bit like bubbles, and lots of bubbles together form a foam. And there's certain rules about how bubbles join with each other. The bubbles, when they come together, make the smallest shape they can and join at an angle of 120 degrees. This is the lowest energy way of doing things and makes the smallest perimeter. And Thompson thought that the silicon was deposited between these joins of bubbles in the cytoplasm, which gives it the intricate shape. And all the different varieties of Radiolarians were just different variations of this theme. It's over 100 years ago since he put this theory forward, and there's lots of mysteries that still remain. It's really difficult to show whether it's true or not, because we can't keep Radiolarians in culture. They die after they're taken out of the sea in just a few weeks. Of course, this is only one part of the story, and lots of things still need answering. But this complexity, in a way, comes from a type of simplicity, which is probably true of how we get all the complexity in life, and how we ourselves come to exist.